Okay, let's dive right in. Welcome to this comprehensive explainer designed to help you completely crush even the toughest Java enterprise engineering interview questions. Whether you're a seasoned developer or you're stepping up into your first major architectural role, we're going to break down the exact concepts that interviewers use to separate the novices from the absolute masters. Take a deep breath. Let's do this. So we're structuring this explainer like an architect's blueprint. We'll be covering core Java and OOP pillars, mastering Java 8 streams, concurrency, threads, and memory, Spring Boot versus Spring MVC, designing RESTful web APIs, and finally, DevOps, Linux, and deployment. All right, Section 1, Core Java and OOP Pillars. Time to lay the foundation. When an interviewer asks you this, it might seem super basic, right? Well, actually, scratch that. It's often a trap for the unprepared. Your absolute best response here is to highlight Java's platform independence, that famous write once, run anywhere capability. You really want to clearly explain that an object-oriented programming language is a paradigm. It binds data and functions together into these highly reusable objects. Now, you absolutely must be prepared to quickly rattle off the 4 core pillars of OOP. Encapsulation hides the internal state. Inheritance allows for code reuse. Polymorphism lets objects take on many forms. Simple enough, but you really need to emphasize abstraction. Explain that it acts as this strict, unbreakable contract. It completely hides the complex, messy implementation details underneath, so your systems can communicate seamlessly without constantly worrying about the how. And honestly, this brilliantly illustrates exactly why those pillars matter so much. Code is read much more often than it is written. When they ask what you keep in mind while writing code, drop this philosophy. It proves exactly why things like clean naming conventions, modularity, and the solid principles are absolutely critical in an enterprise environment. Because let's be real, nobody wants to be the one untangling a massive spaghetti codebase at 2 a.m.
Let's look at how this philosophy builds directly into memory management with String Builder and String Buffer. You've got to know that String Builder is way faster. Why? Because it completely lacks synchronization overhead. But the catch is, it's not thread safe. String Buffer, on the other hand, is thread safe, but it's slower. Knowing exactly when to pull which tool out of your belt proves you understand that incredibly delicate balance between raw performance and system safety. Moving on to Section 2, Mastering Java 8 Streams. Let's install the high-speed plumbing.
If they ask if you have experience with Java 8 or higher, please don't just say yes and stop there. You need to explain that Java 8 wasn't just some standard update, it was a massive paradigm shift. It moved Java aggressively towards functional, declarative data processing, bringing in absolute game changers like Lambda expressions and the Stream API. The absolutely crucial insight to share here is the definition itself. A stream does not actually store data. Think of it like a giant water pipe. The pipe itself doesn't hold the water long-term, it just carries it from a source through lazy intermediate operations like filtering out the junk or mapping values, before finally slamming into a terminal operation like collecting the data to actually produce a final result. Which brings us to Section 3, Concurrency, Threads, and Memory. Let's look at the internal mechanics. Okay, to answer the classic process versus thread question perfectly, use this exact contrast. A process is heavy. It's totally isolated, running with its own independent memory space that gets allocated directly by the operating system. A thread, however, is a lightweight execution unit running inside that process. But you have to remember the catch here. Because threads share that same memory space, communication between them is blisteringly fast, but it introduces major concurrency risks. You literally have to use careful synchronization to avoid a total disaster. And speaking of memory, how does Java actually clean it all up? Well, think of the garbage collector as this relentless, automated maintenance crew, systematically moving objects through specific stages. Brand new objects, they're born in the Eden space. When that area fills up, a minor sweep triggers, pushing the survivors over to the survivor space. Eventually, those stubborn, long-lasting objects are promoted to the old or tenured generation. And that space is only cleaned during a massive, resource-heavy major garbage collection. All right, Section 4, Spring Boot versus Spring MVC, Constructing the Framework. Oh man, interviewers absolutely love this question. Your pivot here needs to be completely focused on developer productivity. Explain how these tools, especially within the Spring ecosystem, use dependency injection to just totally eliminate massive amounts of boiler code. The whole goal is to get that out of the way so you can focus 100% on writing pure business logic.
Spring MVC is great because it gives you incredibly manual, granular control. But it requires setting up dispatchers and deploying to external servers, which is a headache. Spring Boot completely revolutionized this. It provides auto-configuration based entirely on your dependencies, and, this is the kicker, it actually embeds the server, like Tomcat or Jetty, right inside the application jar. It's essentially a self-contained deployment powerhouse.
Moving right along to Section 5, Designing RESTful Web APIs, connecting our app to the outside world. Now, this is a heavily scrutinized area in interviews. When you're asked to differentiate HTTP methods, you must always anchor your answer using one core concept: idempotency.
So, here is the exact breakdown you want to give. Post creates a brand new resource, and it is neither safe nor idempotent. Put, on the other hand, is used to update or entirely replace an existing resource. Idempotent, that's the magic word. Explain that sending the exact same put request multiple times leaves the resource in the exact same state. This is absolutely vital for network reliability. Think about it. If a user's connection drops and their phone frantically retries the request, you definitely don't want to charge their credit card twice, right? And if they start grilling you about handling huge data loads or what kinds of API metrics you're actually used to, casually drop in a real-world metric. You might say something like, well, in my last production system, our core microservices routinely managed 500 to 1,500 requests per second. And if they follow up by asking how you prevent completely crashing the client when returning millions of records at those crazy speeds, you tell them database pagination and utilizing HTTP compression headers like gzip. Bam. Next question.
Which brings us to our final layer. Section 6, DevOps, Linux, and Deployment. Securing the building.
Look, you need to memorize these commands. A true enterprise architect has to be totally comfortable troubleshooting production issues directly in a stark Linux terminal. If a server is crashing, you use df-h to check if the disk is just completely full. If a service refuses to start, netstat checks if the port is already being hogged by something else, and top or ps aux will tell you exactly what your Java processes are doing to the poor CPU.
Next, seamlessly walk the interviewer through an automated CI/CD pipeline. Explain that a simple code commit in Git automatically triggers Jenkins to compile the code and run unit tests. If everything passes, a Docker container image is generated, pushed to a registry, and then deployed into a cluster like Kubernetes. Explaining this whole shebang proves you understand that actually writing the code, that's really only half the battle in modern software engineering.
Finally, we reach the end of the interview. They will almost certainly ask what you've learned recently. Always conclude by demonstrating a serious hunger for continuous learning. Mentioning that you are actively studying how virtual threads and Project Loom are completely revolutionizing Java concurrency will leave them incredibly eager to see how you'll handle the future of their enterprise systems. So the foundation is laid and the blueprint is yours. The only question left is, what new technology are you going to master next? Think about it, and we'll see you in the next explainer.